Day 53, Honors Physics, Rotational Equilibrium, problem number 22. Here we have a person that weighs 700 newtons hanging from the middle of a bar, this red line that I've drawn, dead center of that bar. The bar has negligible mass, it says that, light bar. And I've labeled the diagram with X's because we don't know the distance, but we know that this distance here, X, equals this distance here, X, because it's a uniform bar, and the trapeze artist is in the dead center, the center of gravity of the bar, so it should be X on either side. You're going to find out that whatever X is will cancel out in the problem later on. The other thing is that the ropes make a 20-degree angle with the vertical. If I drew a vertical line straight up here, vertical line straight up, maybe I'll try to do that once. If I draw a line straight up, I'll do a dash line, then I'm going to erase it. That's 20 degrees right there. It says the ropes make an angle of 20 degrees, both ropes 20 degrees with the vertical. That means with the rod it's 110 degrees if you measure that angle, the obtuse angle like that. On the other side with the rod it'd be 70 degrees, but 110 degrees with the rod. Let's see if I can erase that. Yeah, which will be handy in the torque calculation here in a minute, because those two forces or ropes or cables are not perpendicular to the rod like we normally like. So bottom line, I'm picking point A as my reference point for torque calculation. If you go over here, so I got my clockwise torque equal to counterclockwise torque. Clockwise torque, reference to point A, will be this force trying to make it rotate clockwise, 700 newtons, because their mass is 70, their weight is 700 newtons, times the distance of X from the reference point of A, equals T sub 2 times its distance, which is 2X, all right, times the sine of 110 now instead of 90. Whenever it's sine of 90, like on the left-hand side here, I don't write that. Sine of 90 is 1. Interestingly enough, the sine of 110, and you check it out, is the same as the sine of 70. So even if you would have used an angle over on this side of the rope, that's a 70-degree angle over there if I can extend the rod. Sine of 70 and sine of 110 are the same value, so you could have used either angle there to plug in for this torque calculation. But I have my 110 angle labeled, so I'm using that. It's more obvious there. So bottom line is then the X's there will cancel out, and solve for T. You get a value for T sub 2, and we assumed everything was symmetrical here, so T sub 1 is also the same answer as T sub 2. Another check on this would be to figure out the vertical components of T sub 1 and T sub 2. And together they'll be 700 newtons. Oh, by the way, actually that just makes them each 350 newtons. That's another way to do the problem because of symmetry here. Each of the vertical components of T1 and T2 is 350, total of 700 newtons up. And you could have just done this by vector components. You wouldn't even have needed to do torques here. That's another way to do the problem.